Okay, so we're moving on from section 6.1. We're moving on to section 6.2, which is point slope form. Now, point slope form is very similar to slope intercept form. In fact, they're the same thing, just laid out differently. Slope intercept form is still a line. It's still a linear equation. Point slope form is also a line. It's also still a linear equation. It's just a different way of writing it. Think of it like when I think of form, I think of formation. So think of it like, there are different formations on a football team, right? On the offense has different formations to line up, but it's still the same offense. You can have the same people on that line on the offense, and they still abide by the same set of rules. And it's all the same thing, but they line up in a different way, a different formation. That's what this is. You're very familiar with slope intercept form, which is y equals mx plus b. And, point slope form is the exact same thing, but again, it's a different formation. It's a different layout. So point slope form is actually going to be this. Y minus y1 equals m parentheses x minus x1. Now, slope intercept form is called slope intercept form for a reason, because it's comprised of the slope and the y-intercept literally in the equation, right? Slope and the y-intercept are part of the equation. Thus the name slope intercept form. Point slope form, well, guess what? It's also got a name after exactly what it has. Point slope form has a point and a slope. M is going to be the slope, just like M was the slope in slope intercept form. And our point is this x1 and y1 pair. The x1, y1 is an ordered pair, and they make up a point on the graph. And then the x and the y are just the same x and y that is always in the problem, even going back to the slope intercept form. But that is your point slope form. So what I want to do first is kind of get you used to what point slope form is. Now, look down here at the bottom of page 249 and look at the example here on example A. Now, we're asked, hey, write an equation in point slope form for each line. So what we're given here in example 1 is we're given, okay, slope is 3.5. And -3, +2 is a point on the line. Remember, the -3 is the x value, and 2 is the y value. So here's your formula, if you will, for point slope form. So all they're doing is simply just putting these numbers in the formation. Okay, basically lining up on the line of scrimmage. If you think about it in a football perspective, they're not using this equation for anything. They're not graphing anything with it. They're not trying to figure out answers to other problems. All they're doing is just setting it up, lining up, right? Putting the numbers in position, but not really doing anything with it, not running any plays. So the slope is 3.5, and m represents the slope. So you can clearly see they put 3.5 in that space for m, because 3.5 is the slope, m is the slope. Now, y1 is the y value of our ordered pair, which is 2. So they've got that. And the x1 is the x value of the ordered pair, which is -3. So they've got that. So there's your formation. And when you simplify it, it looks like this. Now, but there's one main thing here that I want to point out to you that's going to try and trick you as we go about doing more of these. And that's that if you look back at the point, right, the x value is negative, right, a -3, and the y value is a +2. But when you look at the answer, it doesn't look that way. The y value here looks like a -2, right, because of the minus sign. And the x value here looks like a +3 because of the plus sign. When in reality, that 3 is a -3, as we saw from the point that it came from. And this 2 is actually a +2, not a -2, as we see from the point that it came from. And the reason why this is because the formula is built in with these minus signs. So when you put a negative number in with that minus sign, that actually ultimately disguises it as a plus sign, right? A double negative shows up like a plus. Whereas when you don't have a double negative, you just have a regular negative, and it looks like a minus sign still. So be very cautious of that. A -2 here actually indicates the fact that this y value is a +2, And then a plus 3 here is really indicating the fact that that's a -3. So be careful of things like that. So one thing I want to practice real quick is I'm going to write a few equations out, and I want us to kind of guess what the point and the slope of the equation is, right? So let me give you some point slope equations. So y minus 4 equals 1/2 x plus 2. Now this is a point slope equation, y minus y1 equals mx minus x1. So if I ask you, hey, what's the slope of this equation? You're going to look here at the 1/2. The slope is 1/2. Now if I ask you, well, what's the point in this equation? This is the part that's tricky. The x is always next to the x, so the 2 is the x, but remember that plus is really disguising the fact that it's a negative, and that's actually a -2 for the x value. And the y is next to the y, but it looks like a -4. However, that -4 really indicates that that 4 was actually born as a +4. So the x value here and the y value here are opposite from how they appear. Remember, a plus is disguising the fact that that 2 is negative. And the reason why is because, remember, the formula is x minus x1. Well, if that was the case, then it was x minus -2. That's how that showed up as a positive, ultimately. So it was a -2 originally, whereas y minus y1, doesn't have the double negative, means that 4 did not double negative itself, so it is a +4. One of the things we be careful of. So let's look at, let me give you a few more. Y plus 7 equals -2 x minus 9. In this case, the slope would be this -2. And then the point on here is going to be +9, -7. +9 is our x, -7 is our y. Again, it's going to take some getting used to the fact that it's kind of opposite from how you appear, but you'll get used to it. Also, note that slope does not change its sign, right? A -2 is a slope, it's a -2. That doesn't change. It's just the x and y. It's just the point down here that you've got to be careful of. So let me give you one more. So let's say I have y plus 3 equals, we'll say 2, and then x plus 1. In this problem, the slope, or this equation, the slope would be 2 for this one. And then the point would be, x would be a -1, and y would be a -3. Again, opposite from how it looks. So keep that in mind as we go throughout more of these problems. If we look at number 3 and number 4, we know we're going to do the exact same thing. So write an equation in point slope form with the slope of 6, and then it goes on the point 1, 2. Now remember, the x is the 1, the y is the 2. Let me write out the general formula first. Y minus y1 equals mx minus x1. So the y value is a +2, which means when I write it in here, it'll look like a -2. So y minus 2. The y value is 2. That's why I'm plugging 2 in for this y1 spot. And since it's +2, I left it as a -2. The slope is 6, so I'm going to replace that m with 6, and then we're going to have x minus the x value. So the x value is 1, so since it's positive, I'll leave it as x minus 1. And this is the correct equation with the slope of 6 and the point 1, 2. Okay, we could try this. If you want to pause it and try it yourself, go for it, see what you can do. But I'm going to go ahead and write out the answer. So our answer would be y minus 1 equals 1/3 x plus 3. All right, so just to explain it real quick, the slope is 1/3, so that's why this m value is 1/3. That's pretty straightforward. The x value here is a -3, so the x value, remember, x goes next to the x. So the 3 here is the x, but because it was negative, I put +3. Again, opposite from how it seems. And then the y was the 1, so I put it next to the y, and it says -1 since the 1 was positive. So just some good practice there. Okay. Now, Paul would like to shop for the best price to place an ad. A different newspaper has a base cost of $15 for 3 lines and $2 for every extra line. How much will an 8-line ad cost in the paper? So we're going to write our equation point slope form. Now, the only way I can do that is if I know a point and a slope given from the problem. So let me zoom in on this a little bit. All right, point and a slope. Now, if I read the problem carefully, I'll see that it costs $15 for 3 lines. That right there is a combination of two things that kind of go together, that are linked together. 3 lines is priced at $15. So right there, I know that my point is 315, and I know it's 315 rather than 15.3 because 3 lines is the independent variable, 15 is the dependent. Essentially, the amount of money we pay depends on how many lines we get. Another way of thinking about it is usually money is your dependent variable, because money depends on a lot of things. So typically money is going to be the y value. So anything that's related to money typically ends up being the y value. All right. Now our slope is our change over time, rate of change, which in this case is $2 every extra line. So every additional line we get is 2. So it's an increase of 2 every time, making the slope 2. So when we put this information in our point slope equation, you can see here's the general equation. They've already plugged the 2 in for our slope. Thank you very much. The y value that's going to go in this first box is 15. Is our y value. And then the x value is going to go in the other box, will be 3. So now this is the equation. We're done writing the equation. This is setting up our formula, or setting up the formation, right? But now we're actually going to run a play. We're actually going to use our formation. So in order to use it, we're asked how much will an 8-line add cost? Well, remember 8 lines. Lines is the x value, like 3 lines is the x value, because it's the independent variable. So this is actually an x value we can plug in into our equation and then evaluate for y. So we're plugging the 8 in for the x, and we're just evaluating. So when I simplify, I'm going to do the parentheses first. So 8 minus 3 makes 5. So this becomes 2 times 5. And 2 times 5 makes 10. So y minus 15 equals 10. And then if you add 15 to both sides, we end up with y is equal to 25. So 8 lines cost $25. Now, there's another way you can do this using slope intercept form. Remember, slope intercept form is y equals mx plus b. You can actually still use this form. You actually don't even need point slope form. So to show you this, you would still need to know the slope is 2 and the point 315. The problem with this form is you kind of need the y-intercept, right? Well, what is the y-intercept? Typically, that's the starting amount, the amount that we have in the beginning, but it doesn't tell us that in this problem. So we actually don't know what this number would be, which is why it's sort of impractical and why you probably would prefer to use point slope form. They give you a point, they give you slope, so it only makes sense to use point slope form, over the slope intercept form, because it gives us a slope, but it doesn't give us a y-intercept. So it's a bit impractical, but it's still usable. And let me show you. So if I want to use this, I know, 2 is my slope, but everything else I'm pretty unsure of, right? I don't know what the y-intercept is. But what I could do is I can use the point that it gave me. I can plug that in for the x and the y and solve for b. So let's use that. Let's use this information. Let's use the 15 as the y. Let's use that 3 as the x, and then I can evaluate and figure out what the y-intercept would be. So just solving this, 2 times 3 makes 6. All right, so then just to solve it, I'll subtract 6 on both sides, and I find that 9 is equal to b, meaning that 9 is the y-intercept. So the correct equation would be y equals 2x plus 9. So this equation is the same one as this. It's just in a different form. And you could still use it to evaluate how much 8 lines cost. You can still plug the 8 in for the x, and we would still get the same answer. 2 times 8 is 16. 16 plus 9 is 25. I still get the same answer. And also, if you don't believe me that this equation is the same as this equation, well, let me show you another thing. Y minus 15 equals 2x minus 3. Remember, this equation is the same one that we wrote originally, right here. And I'm going to simply rearrange it, and you'll see that it's going to be the exact same equation that we got here. It's going to be y equals 2x plus 9. So let me show you that. It's very simple, very easy, just 2 steps. I'm going to distribute these parentheses here, and then I'm going to move the 15 to that side. So first, let's distribute. So 2 times x will be 2x, and 2 times negative 3 would be negative 6. So that's just distributing there, and let me bring down this other side, y minus 15. When I add 15, I'll cancel that out, and I'll move it over to the right side. And this leaves me y equal to 2x. And now negative 6 plus 15, it's very similar to what we kind of had over here. Negative 6 plus 15 is positive 9. And it's the exact same equation. So all this math is linked together. You know, slope intercept form, point slope form, you know, using it and getting the same answer. It's all the same thing. So I really wanted to show you all of this. Even though the problem was really just this, I wanted to show you all this information just to sort of tie everything together. And I know I did it kind of quickly, so I'd recommend maybe going back and rewatching what we did here, knowing what the outcome is, looking for those things all linked together. It might help you understand it even better. So moving on, the next thing we're going to do is creating a linear equation given 2 points. So we're going to do the same thing. We're going to make slope-intercept equation like this, but we're only going to have 2 points. If you look back at the problem we did before, we had the slope and the point, so it's very easy because all we had to do is just plug those numbers in. But what if I'm not given the slope? You know, if it gives me just 2 points, well, to make point-slope equation, I need a point, which is fine. I have 2 of them, so I don't have a problem there. But I need to know the slope. The only way I can make a point-slope equation is if I know what to plug in for the m value, right? Y minus y1 equals mx minus x1. I have points. I know I can plug in for the x value and the y value here, but I don't have a slope. So what am I supposed to put for m? So that's part of the problem here is we're going to use some information, use the information we have to figure out what the slope is. And it's not hard. When you have 2 points, you can find the slope very easily using the slope formula. So this problem's already worked out, but I'll show you what they did. So essentially, remember, each point here is an xy ordered pair. So the slope formula is simply saying the y values minus each other over the x values minus each other. There we go. Y values on top, x values on bottom. And yes, it starts out as a fraction, so you are going to write it out like a fraction. But typically, a lot of the time, our final answer doesn't end up being a fraction, which is very nice. And you see how this one worked out. So the y values are 4 and 1. So they're subtracting those. That's why they're doing 4 minus 1. And then the x values are 3 and 2. So that's why they're subtracting them, 3 minus 2, right? So they're subtracting the y values and subtracting the x values. The y's go on the top, 4 minus 1 is 3, and the x values will go on the bottom, 3 minus 2 is 1. Now, this is still a fraction, yes, but it's really a number when you simplify it. 3 divided by 1 is the number 3. So the slope really is just the number 3. And so there are 2 ways you could write your answer. Both of them, of course, have the slope of 3, since that's what we've just discovered, but they differ in the point that they use. The first equation uses the point 2, 1, meaning it plugs the 1 in for the y and the 2 in for the x, but it's still the same point. The second one uses the other point, 3, 4, plugging the 4 in for the y and the 3 in for the x. Okay, but they're both the same equation. They might look different, right? But they're still the same equation. And again, what I want to prove real fast is that they're the same equation. Okay, and I want this to become a skill that you guys can do. I showed you it just a second ago, but it's rearranging these equations into slope-intercept form. And you'll note that even though these 2 equations, they look different, they're actually still the same equation. And I'm going to prove it to you by putting them both in slope-intercept form. So let's try this first one. Y minus 1 equals 3, x minus 2. So to put this in slope-intercept form, remember it comes down to 2 things. Distribute to these parentheses and then move this 1 over. Now to do that, we'll distribute. 3 times x is going to be 3x, and 3 times -2 is -6. So we have 3x minus 6 after distributing. We'll bring the left side down. Then we'll add the 1 to cancel it out. We'll add the 1 to the other side. So this is going to be y equal to 3x, -6 plus 1 makes 5, or -5. So 3x minus 5. That's the equation. That is the equation in slope-intercept form. Now you'll notice the second equation, this other one down here, I haven't looked at yet. This is going to give us the exact same answer. It's going to give us the same equation because it's the same equation, just again, a different formation, a different format. So it was y minus 4 equal to 3x minus 3. So same two things. Distribute here and then move the 4 over. So when I distribute, 3 times x is 3x, and 3 times -3 is -9. So let's bring down the left side, minus 4. So now just move the 4 over. Since it's minus 4, we'll add 4 to cancel it out. And guess what? We have y equals 3x, and -9 plus 4 is still -5. So these are still the exact same equation, and you could see it a little more obviously when they're in slope-intercept form. So it's very important that we're able to do this, that we're able to put these equations in slope-intercept form. It can come pretty handy because slope-intercept form, in my opinion, is a little more useful, a little bit easier to use than point-slope form. But, you know, there's, like I said, all this math is tied together one way or another. So if you're an expert at it, then you can go from one form to the other without really any problems. Okay. Now, if we look at number 8 and number 9, we're going to try this as well. If you want to pause the screen, if you think you got it, you know, from our first example, go ahead and try it yourself. Otherwise, let's watch and let's do it together. So remember, to write this in point-slope form, I need a point, which I have 2 of, so that's not a problem, and a slope, which I have to calculate. So the slope, remember, is y minus y, and x minus x. It's going to start out as a fraction. So our y values are 1 and 4. So we're going to subtract those. I always like to do the second point minus the first. So let's do 1 minus 4. So that's 1 minus 4. Those are the 2 y values being subtracted. On the bottom, I'm going to do the x values. Now, since I did 1 minus 4 on the top, right, I started with this point and I subtracted this one. Since I did 1 minus 4, I have to do 3 minus 2. I have to do it in this order. Because if I start with 1 for my y's, then I have to start with its corresponding 3 for my x's. What I can't do is I can't do 1 minus 4 and then 2 minus 3, because that's going starting at different points, and that's going to mess us up with our values. So if whatever point you start with, you have to start with for the x's as well. So when you calculate, so remember I'm doing 1 minus 4 and 3 minus 2. When I calculate, 1 minus 4 is -3, 3 minus 2 is 1. And again, it's a fraction, but it's a fraction that's a real number. -3 divided by 1 is still -3. So my slope is -3. So now I know my slope, and I have 2 points, so I can just pick one of them. So let's pick this first one. To write it in point-slope form, this would be y minus 4 equal to -3x minus 2. And you can see again, the 4 is our y value. The -3 is our slope as we calculated, and then this 2 is our x value. If you use the other point instead, you would have y minus 1 equals -3x minus 3. Again, still the same equation, just uses the other point. Okay, so either of these is correct. It just depends on which one of the points you wanted to plug in. Either of them makes a difference. So if you want to try this one, again, you can pause the screen, go for it, and then come back to it. All right. So here's our answer. Remember, we need to find the slope. We already have the points. We need to find the slope. So y is minus y. So xy, xy. So I'm going to do 1 minus 1. So I'm doing the second one minus the first one. So on the bottom, I'm going to do the second x minus the first x, which is 1 minus 0. So I calculate 1 minus 1 on top is 0, and then 1 minus 0 is 1 on the bottom. Now again, it looks like a fraction, but 0 divided by 1 is still going to be the number 0. So my slope is still going to be 0. So I have my slope and I have 2 points to pick from. So these are what your 2 possible answers could look like, just depending on which point you use. If you use 0, 1 as your point, your answer would look like this. Y minus 1 equals 0, x minus 0. Because the y value is 1. The slope is 0, as we calculated. And the x value is 0 from the point that we chose. So you could do it that way, or you could use the other point, which would look like this. Y minus 1 equals 0, x minus 1. So that would work out just as well. All right. Now, number 10, in our last problem that we're going to do together, at least in this video, is this word problem. So this word problem, a gas station has a customer loyalty program. The graph shows the amount Y dollars that 2 members paid for X gallons of gas. Use an equation and point slope to find the amount a member would pay for 22 gallons of gas. So we have 2 points given to us on the graph. That's what we're going to use. It's basically the same problems that we've been doing. We have these 2 points. That's all we really need. And we can write our equation in point slope form. But then remember, we're going to use the equation to find out how much 22 gallons of gas costs. So let's start by finding our slope, because we already have 2 points, so we're good there. But I need to find the slope. To find the slope, we're going to do y minus y. So I'm going to do 49 minus 10, the top y minus the bottom, and then x minus x, so 18 minus 5. And when I solve this, this ends up being 39 over 13, and 39 divided by 13 ends up being 3. So our slope is actually 3. So when I plug this into a point slope equation, I would have y. I'm going to plug in, I've got 2 points to choose from, but I'm going to plug in the second point here, the bottom point, just because the numbers are smaller. So if I do that point, then it's going to be y minus 10 equal to 3 as the slope, x minus 5. And there's our equation. That's point slope equation. I've got the point 5, 10 as my x and my y, and I've also plugged in the slope 3 that I calculated. All right, but now, remember, we're not done. We have to use the equation to find out how much we'd pay for 22 gallons of gas. So 22 gallons of gas, this is our x value. So simply plug this in for the x and then continue to solve. So if I plug 22 in for x, we'd have this equation. Y minus 10 equals negative 3, and then 22 minus 5. So when I evaluate, start with the parentheses. 22 minus 5 is 17. So this would be negative 3 times 17. And then I would multiply those. Negative 3 times 17. Is it negative 3? Oh, it's positive 3. I don't know why I wrote negative 3. Right? It's positive 3 right over here. Right? 3 times 17 is 51. So y minus 10 is equal to 51. And then add 10 to move it to the other side of the equation. And we end up with y is equal to 61. So that's the actual answer to our equation, is 22 gallons of gas would cost $61. But I also want to show you again, same thing that I showed you before. Here's your point slope equation, right? It's the point slope equation. How easy it is to do this problem if you convert it into slope intercept form. Remember, to convert it to slope intercept form, you would distribute this first and then move the minus 10 over. So when I do that, it's only a 2-step process. 3 times x would be 3x. 3 times negative 5 would be negative 15. So bring that side down and then move the 10 over. So since it's negative, I'll add it to move it over. And I end up with y equal to 3x minus 5, because negative 15 plus 10 is negative 5. So this is the exact same equation as that, except this one is in slope intercept form, which also tells us that our y-intercept is negative 5, which is just good to know in case you were to graph it. But the reason this is better in some cases is it's easier to plug that x value of 22 in to this equation than it is the point slope equation that we did. So we can actually plug the 22 in and get the answer a little bit faster here. 3 times 22, then minus 5. This comes out to be 66 minus 5, which still makes y equal to 61. Again, same answer. So all this math is tied together. It's all the same thing. They're all linked. Point slope form, slope intercept form, plugging it in, using it, it all does the same exact thing. But they're just different formations, different ways to run your offense. Okay, some plays work better in certain circumstances than others, just like these formations. Some work better in circumstances than others. But it all does the same thing. It all functions by the same set of rules. You can use them the same way. They're interchangeable. So that's it for section 6.2. I'll see you guys in section 6.3.